Okay, so today I'm going to teach you guys about linear inequalities. Before we start, I'm just going to give you a review of the signs. So this sign is x is less than 1, x is greater than 1, x is greater than or equal to 1, and x is less than 1.
Or equal to.
Or equal to 1. If you're going to graph these, you would have an open circle for these two and a closed circle for these two.
Okay, so, whoa. Let me just explain that we didn't film any transitions or anything. So it's just going to be me voicing over because we forgot to film transitions. Okay, wasting time, but basically we're just, you'll see.
Okay, this is a practice problem that we're going to do together. So if you were to solve this, you would need to pretend like this was an equal sign, but it's not. But you pretend like it was for the time being. And you divide this side by -3.
Womp womp.
This side by -3. But since it's a negative sign, you would need to womp the sign. Okay, so it would be x is less than -2. If you're going to write this in interval notation, it would be -infinity, comma, -2. Now, it's in parentheses because the sign is less than with no line underneath it, but if there was a line underneath it, like this per se, it would be brackets.
So once you have your final answer of the inequality, and for this we have x is less than 3, then you're going to graph it on the number line. So since x is less than 3, you mark 3 on the number line, and since 3 is less than, x is less than and not equal to 3, then the circle is left unshaded, and then you draw in the direction x is less than 3. You draw an area above it, and that's how you graph a normal inequality. Special cases for graphing compound inequalities. So for this problem, it's x is greater than 0 and x is greater than 1. So first you're going to graph normally like x is greater than 0. Then you're going to go over graph x is greater than 1. And it has to meet both of these. So here's your giant number line. And next we have our so you would think, oh yeah, this is our final answer, but it has to satisfy both of these equations, and so this would be your final answer because that would satisfy both of the equations. And so your interval notation would be 1 infinity. So next we have our second special case for graphing compound inequalities. So next we have x. We have x is greater than 0 or x is greater than 1. And it only has to satisfy one of these instead of and, which has to satisfy both of them. So first we're going to normally graph how we usually do both of the inequalities. And then you do this. And graph how they would be. But since it only has to satisfy one of them, at least one, then that means that this would satisfy at least one of them. So then the interval notation would be 0, comma, infinity, with normal brackets, parentheses instead of brackets. So next, I graphed both of these inequalities. And so basically, you're going to look at them now and bring them basically together into a final number line. So first you have your x, that, so you graph that again. It's going this way. But then you have this 5 that's going this way. But it has to satisfy both, so it can't go past -1 or past 5. So this is your final answer. Are you ready to see where it's going?
Yeah, I've been trying.
So then the interval notation will be parentheses 1, comma, 5, like -1, comma. Yeah. So next we have our third special case, and it's y is greater than or equal to 6, and y is less than 2. And it has to satisfy both of these equations. So first, we would graph out our inequalities, like usual. But then we have to, yeah. And so it would be, but since it has to satisfy both of these, and if you combine them together, they don't satisfy either of these equations. If you combine them together, that leads it to an all real numbers problem.
No solution problem, Lucy.
No solution problem. So now we have our final special cases for graphing compound inequalities, which is x is less than -2 or x is greater than -5. And we're gonna do what we usually do, and graph this one. And next we're gonna combine them. And so you would get, and since it has to satisfy one of the two, and it's satisfying both of them, it leads to all real numbers. So that would be its interval notation. Okay, so now we're going to graph linear inequalities. The problem is right here. The slope would be -1 because this would be 1 x over y, so 1. Okay, so now you're going to graph it. This is your y-intercept, so you graph it right here, and you follow your slope.
Guys, we're vlogging. We have no clue what we're doing. Actually, it's more Lena doesn't know what she's doing, but Lucy does. Oh yeah, she's right though. Oh my God, Lucy's right. Subscribing.
I don't know what y is, so I don't really care about it. We're gonna do a YouTube video about how to do this.
Okay, so I drew a straight line because it is a greater than or equal to sign, but if it was just this, then it would be a dotted line, but it's not. I also shaded on this side because you want to know what side to shade on, so I chose the point 0, 0 because that's easier, and it's not included on our line. So we're just going to plug it in for both x and y. Which is the same as 0 is greater than or less than 2, or greater than or equal to 2, which is not true because 2 is obviously bigger than 0, which is why we shaded on this side, because 0, if this was true, then 0 would be included, but it's not true, so 0 can't be included in our shading. So we shaded on this side.
So basically, it's finding the best fit line for a set of data points. So let's just say I had an experiment and I got these points. It would be like finding a line that perfectly goes through this, like these sets of data points. So first of all, we're going to go over this. This would be, if it was this way, this would be a positive line. But if it were to go this way, it would be a negative line. You know, just like on a graph. So next, oh, and then also, if it was just a horizontal line, there would be no correlation. And you're probably like, what is correlation? But that's determining the strength and or direction of the relationship between two variables. So there'd be like, it's basically like there is no like strong points or anything because like the lines were too scattered, so there isn't correlation because it's not strong enough. Does that make sense? Okay. But then there's strengths of a line. Yeah. So next there's strength of a line. So a strong line can be positive or negative, but it's basically if the points are really close together, then it's a really strong line. But if the lines were really far apart, it would be a weaker line and closer to no correlation. So next, we're going to analyze linear regression. Yeah. So the R value, so here's our calculator tutorial. Mom looks at me and like really keep the screen to help. Okay. Okay. So after you just saw that, you found out your R value in that, like after you calculated it and found your equation and whatever, after finding your table, whatever. So you found your R value, and that shows how strong, like this is, shows you how strong your line is and your direction of the line, whether it's positive or negative. And if R is close to 1 or -1, it's considered a good fit and a really strong line. But if it's closer to 0, it's a weaker, not good fit line and closer to no correlation. And then if R is equal to 1, it is the perfect fit and it goes through and it's going through all of the data points on the line. But if R is 0, there is no linear relationship between the two variables, which is no correlation.
Okay, so first we're going to input our data by hitting stat, then edit, and then you're going to fill in your data on your columns of L1 and L2. L1 is going to be your independent variable, and you're on your x-axis whenever you're graphing, and then L2 will be your y-axis and your independent variable whenever you're graphing. Next, we're going to plot our data by hitting second, y equals stat plot. You turn your plot on to make sure that you can plot your data, and it's on, as you can tell. Next, we're going to graph our data by hitting zoom, then zoom stat all the way at the bottom, and now you have it graphed. So next, we're going to hit stat, then calc. Then we're going to go down to linear regression, ax plus b. And then we're going to scroll down and hit calculate. Next, we're going to graph our line by hitting y equals. And then we're going to type in our equation right now. Ooh, we're typing it in the form of ax plus b. And then we're going to graph that. If you want to see the linear regression being performed, then you go to stat, then go to zoom stat, and then you can see that it's graphed.
So the final thing that we're going to learn about is extrapolation, which is analyzing outside of your range of data. So if you have like a table and it's asking for if it was 5, what would it be? That would, if you found out the answer, that'd be extrapolation because it's outside of range of data. But if you ask for something like trying to find what 2.5 would be, it wouldn't be extrapolation because you don't know what's outside of this range of data and it could have gone berserk because we don't know. So it's always good to not extrapolate and just guess inside of the range of data because it may not be accurate.